Good morning, all, and welcome to today's webinar on restoring the upper reaches of Chalk Stream. For anyone who's not seen me before, I'm Becca Duncan and I'm the Media and Events Lead at the Rivers Trust. We are starting very promptly today as we have a real packed agenda and don't want you to miss out on any of the content. But before I introduce my colleague Alison, I'm going to really quickly run through the housekeeping notes for today's event for you. So first of all, we do have closed captions available on the webinar. You can use these, activate those by clicking the captions button at the bottom of your Zoom screen. You may need to hop onto the More button to get that option up, and you can adjust the size of those settings if needed. We've got a Q&A session at the end of today's webinar, so please submit any questions that come up throughout the event via the Q&A function to ensure they are seen by our panelists and our chair, David. For any kind of more informal comments or feedback on people's presentations, then you are very welcome to use the chat function for that. And finally, today's webinar is being recorded, so the recording and all the associated resources will be made available via the Catchment-Based Approach website in the coming days. But that's it from me for now. I will hand over to Alison, our Chalk Streams Programme Manager.
Hi, good morning. It's fabulous to see so many of you here for this event. This is a bit of an experiment for us. This is a new thing. We're trying to establish a bit of a community of practice around all of the people that are involved in designing, delivering chalk stream restoration projects. And we're doing this with the River Restoration Centre in the form of what we're calling a chalk stream hub. So this is all really about sharing knowledge and experience, and you're going to hear some great projects today, and there are many more that are happening out there. So in the chat, please feel free to tell us about the projects that you're delivering as well. It'd be great if you want to offer to present about them in the future. That would be very welcome, or even offer a site visit, which would be fabulous. So this is a bit of an experiment. I think I'm probably trying to pack too much into one meeting because we have quite a lot to get through. So I'm not going to talk for very long. And just to say, if you've got any feedback or ideas about what would be useful from this kind of community of practice river restoration hub idea, then please do let me know. I'll put my email in the chat. And also, I know on Zoom calls you can't see who's on the call. I can see there's over 100 of us, which is a fabulous attendance. Really pleased to see so many people interested. But in the chat, please do, if you feel like you want to, just say hi, where you're from, and maybe what organisation you're from, just so that others on the call can get a feel for who's involved in this community too. And hopefully this will be the start of a series of events and things that will really help support the delivery of fabulous projects over the coming years. So without further ado, you may have seen the agenda on the slides rolling through at the beginning. We start off with Tim Sykes, who's going to talk to us a bit about the ecology and the importance to people of winterbournes, which is a really great place to start. We're then going to move on here from the Wessex Rivers Trust team about work they've been delivering in Hampshire. Then on to the Chilterns with Adrian to talk to us about the Hamble project, finishing off with Matt up in Lincolnshire, who's going to talk to us about some of his experiences with Stage Zero projects and not just chalk streams. We're going to branch out and hear about other rivers too. And hopefully, if I manage this properly, we'll have enough time at the end for some Q&A, which will be chaired by David. So without further ado, I'd love to hand over to Tim, please, to kick us off.
Good morning. Can you see my screen?
Yeah, it's not on full screen view yet, Tim. It's
not yet. Okay. How's that?
It's just coming up, I think.
Yeah.
Everything seems to run slowly.
Here we go. Yes. Okay. Hopefully you can see that now.
It's there now. Thanks, Tim.
Good. Thank you. Sorry for the delay. Well, good morning, everybody. Yes, my name's Tim Sykes. I'm an ecologist for the Environment Agency in what we call Solent and South Downs area. And I'm also a part-time PhD candidate at the University of Southampton, where I'm looking at our relationship with chalk stream headwaters that are temporary and called winterbournes. Alison has invited me to come along and help kick off this morning's session by describing why I think winterbournes are so special. We don't have much time, so see, these are the things I'm just going to touch upon. But let's dive straight in at the beginning. The source of a lot of these headwaters varies in space and time, both within years and between years, and differs between catchments. So the picture on the left here shows the source of the river Itchen. On the OS map, it's marked as being in the woodland, off to the right of the picture there in the woodland. But when groundwater levels are high, it actually emerges much further up the dry valley. So it's ephemeral in time and space. The picture on the right is a chapel built literally on the source of the River Nailbourne in Kent. And the picture on the left here, top left, is Swallowhead Springs in the Kennet Valley. It's a natural spring at the break of a slope, and it's a site of pagan rituals people go to and leave votive offerings, including once a placenta. And all of these headwaters are ephemeral. And they're probably important to people probably because of that. Far less accessible are other springs in winterbournes, especially those on the north scarp face of our chalk escarpments, our chalk downlands. Here the slope is very steep and it's dissected by deep ravines. These views are different springs in the north face of the South Downs. They're heavily wooded, people can't get to them, but they are still temporary. Another feature of winterbournes, which is really important, is their bed, made up of fragments of flint and chalk. The hyporheic zone is the zone through which water can flow both laterally but also vertically. And that verticality of groundwater is how winterbournes and chalk streams in general thrive. Water comes up and down through the bed, not necessarily along from rainfall in the headwaters. So the hyporheic zone is critical for a wide variety of ecosystem services. And in winterbournes, they're especially important because in the spaces in the gravel is where some aquatic invertebrates can live out and survive or tolerate the dry phase. That's important for us as managers and restorers of winterbournes, because when they're dry, don't be tempted, for example, to drive your machinery up and down them, and where you might compact the gravel, lose those spaces that are so important for aquatic invertebrates. So even in their dry phase, they're full of life, including aquatic invertebrates. When they're flowing, they occupy our wonderfully gorgeous countryside. And on the right here, you can see that they have many of the characteristics of a perennial chalk stream. The view there is on the Lavant near Chichester, full of flowering ranunculus, wonderful structure and diversity of riparian flora and fauna. And of course, they have that characteristic gin clear water that allows us to see the trout, to see the abundance of macrophytes, to see the bed of the river. And of course, it allows reflection and refraction of light that really captures our attention. In the ponded phases, as groundwater levels have dropped, the only water left is in isolated ponds in the deepest parts of the channel. These pools become nutrient rich, warm, there's rotting vegetation, and literally thousands of stranded macroinvertebrates and even fish. So they're absolutely critical to the life and death of predators and prey. In the dry phase, they can be visible across our landscape in many cases, and they invite people to get into them, to explore them. If you're curious, you'll look for fossils, you'll handle the rocks, you'll look for wildlife. And that's how many people relate to and value their dry phase. They're colonized by ruderal plants and often by grasses, but those will clear when the flows return. So I've described to you a timeshare of habitat, aquatic and terrestrial, that are equally important. There are those invertebrates, aquatic invertebrates, that have adapted their life cycle to tolerate the dry phase and to remain in situ, so that when water returns, they are already there to rapidly colonize and live out the rest of their lives. But they're equally important for terrestrial invertebrates too. These can be nationally scarce, including number of beetles. I have met people who have described their winterbourne as dead in the drying phase because they equate the material presence of water with life, but that does not apply in winterbournes. And they're important to people too. My research has found that temporary streams are important for people's mental health and psychological well-being. People particularly value the range of phases in the cycle. It reminds them of a connection of nature, a lot like seasonality, or the passage of the moon, the phases of the moon. Of course, in the new moon, there's no moon to be seen, and that's a bit like the winterbourne without any water to some people. And these natural cycles are one way with which people connect with nature. They offer a variety of cultural ecosystem services, those benefits that are intangible that we perceive we get from nature. An example is the wetting phase, that transition from dry to flowing. The water emerges and slowly makes its way down the stream. That can take weeks. And in anticipation of the water first emerging, and then after it starts to emerge, social media in some villages lights up. People are asking, have you seen the winterbourne? Where has it got to today? And in fact, many people travel up and down their valley to bridges to witness for themselves its progression and where they meet other people. And so this phase really engenders relational values, people relating to each other as well as relating to nature. And it goes without saying that this is a phase that perennial chalk streams cannot offer. But that dry phase also invites people to mismanage and damage these winterbournes. It's very easy to fill in a channel and to excavate a completely new one when there's no water to contend with. And so gradually the form and function of winterbournes has become eroded and damaged. How to manage the vegetation in them is particularly contentious. Some villages want them like a cricket pitch, absolutely manicured, others like them wild and woolly. Nobody is always satisfied. And humanity has a propensity to dam and obstruct flowing water, and winterbournes have not escaped that. And we constrain them in ways that really does not optimize the ecological value or the natural processes. Here's two particularly extreme examples. The picture on the right is the Upper Itchen, the Candover Brook, where the winterbourne has literally been ploughed into the arable field. You only know it's a winterbourne when groundwater levels are high and the water traces its former watercourse for us. And the picture on the left is a misguided individual who believes that by excavating his winterbourne, he will improve flood risk to his property. So to help guide and facilitate people to manage these places, we recently published some guidance. This was under the auspice of the Hampshire and Isle of Wight Wildlife Trust's Watercress and Winterbournes project. It involved a collaboration of organisations and is aimed at all individuals and organisations involved in monitoring and restoring winterbournes. It's far from perfect, but it's filling an information gap a void of knowledge to steer people who are interested. It will become better if those of you who are managing and restoring these places carefully monitor the outcomes of what you do, and so that we can feed back and eventually create maybe what might be called best practice. As I get to the end of my talk, I'd like to just emphasize again the value of these places to people. I think we're going to hear today quite a lot about how we're improving these winterbournes for wildlife. We might be introducing large woody materials to create heterogeneity and energy, for example. But what about people? While you're restoring them for wildlife and natural processes, think about how people might be, you can enhance it for people too. So slightly tongue-in-cheek, but maybe think large woody materials for people. This is a bench dedicated to a friend and colleague of mine. It's the type of place where my research participants have said they like to sit by or even in winterbournes to experience tranquility. It allows them to gain a perspective on world affairs and to resolve issues going on in their lives, and also to connect with nature. So next time you're thinking about large woody materials, think about people. So I've run out of time there. These are some of the take-home points I'd like to emphasize. Remember the guts of the river, the hyporeic zone. If you're moving or recreating a winterbourne, it's not as simply as just diverting the water there. You really need the substrate for it to function properly. Design restoration for the range of faces, not just the flowing phase. And bear in mind that these places are special for people and wildlife, not just because they flow, but because they dry out. Thank you.
That was fabulous. Thank you, Tim. Really, really good reminder to bring people into it as well. As a scientist, I get a bit wrapped up in numbers and spreadsheets and sometimes forget that. So thank you. That was fabulous. So now we're going to move on to the section where we're going to see some examples of river restoration projects that have been delivered recently. So we're going to kick off with the Wessex Rivers Trust team, which I think is a bit of a double act between Matt Salter and Andy Blinko, who are going to tell us about actually one of the rivers we saw in Tim's presentation. So I think handing over to Matt to start off with. So do you want to share your slides, Matt?
Yeah, hi all. I'll just share my screen. How's that? Can everyone see that?
Fabulous. That's great. Thanks, Matt.
Brilliant. Okay, just bear with me. So as Alison just said, my name is Matt, and my colleague Andy and myself will discuss two winterbourne restorations that Wessex Rivers Trust and Watercress and Winterbournes delivered last autumn. They are on two separate rivers, and the two reaches we're about to present are examples where restoration of morphological and habitat restoration was undertaken to the extent that local constraints would allow. One is a reach close to the winterbourne source of the Itchen, and the other a winterbourne reach of the Bourne rivulet immediately above the perennial head. Despite both projects being similar in both length of channel restored and cost, restoration required different approaches. We will talk about constraints, the apparent modifications, and the approach taken to reverse those. So the first of which Tim has spoken about briefly, is at Hinton Ampler on the Chilterns stream. And on the Chilterns stream, on this site, there are two distinct reaches. The first reach, upstream of the recognised source of the Itchen, exhibits a gently sloping field with no defined channel, whilst the reach downstream is defined by a modified channelized watercourse. This poses the question of whether we should be restoring land that is sometimes wet or a stream that is sometimes dry. So this is the upstream reach that Tim shared. So here's a photo of it there. It's a field of semi-improved grazing pasture that is seasonally wet with an emergence of water free-flowing through the valley bottom. On occasion, wet flushes of vegetation can be seen growing in the low-lying areas. Despite early aspirations from the landowner to extend the Winterbourne Channel upstream, this was deemed inappropriate, as this reach more than likely never had a defined channel and is instead an example of land that is sometimes wet. Restoration measures instead focus on land management changes. As you can see from the photo, the valley bottom of the pasture is poached and is crisscrossed by track marks. It is proposed that changes in cattle management and, if necessary, fencing be implemented to allow the valley bottom to develop without pressure. A case of see what happens. So moving downstream, this is where you find the reach that has a section of Winterbourne that has been historically widened and bunded, creating a straight, uniform, and degraded channel disconnected from the floodplain. The banks are vertical and dominated by scrub and lacking in any marginal vegetation. So what should the Winterbourne restored to? This is the same reach, but in June, and it exhibits similar characteristics of the previous photo, lacking in both marginal and in-channel macrophytes. This is the elevation model from the drone LiDAR survey, which clearly demonstrates the modified channel. Compared to upstream, the channel is significant, which you may not typically expect to find this close to the source. The source is probably 400 meters upstream, and indeed find any defined channel at all. You can see the bunds on both banks from where the channel has been modified. Here are photos of the gravel found in the bunds, where scrub has become dominant, sitting high and dry. So what restoration approach did we take? As alluded to, it's difficult to know if there was ever a defined channel here, but what is apparent are the historic modifications. We propose to reverse these to create a channel with a more natural channel plan form and profile. In addition, select scrub thinning where it had become dominant to allow more light into the channel. This material was then installed in channel to drive hydromorphological change for enhanced habitat complexity. Where possible, we bed raised when reshaping the channel. However, site constraints, including the A272 culvert at the downstream extent, limited this. So here's a photo that was taken during delivery. It's not often we restore rivers in the dry, and it required a degree of artistic license. Wild Trout Trust, the contractors, had to visualize a stream that wasn't there and shape a channel to receive it. On the left, you have a photo of the modified channel prior to restoration, and on the right, you have the same reach immediately after restoration, exhibiting a much more natural channel profile and plan form. Here's more fixed point photography-ish. This time, a few months later in winter, where the groundwater had returned. Here is an example of a larger bit of woody material that we root bored into the channel. And in March, the mostly absent in-channel macrophytes have begun to establish. The physical restoration was only the beginning. It'll be a joy to see the plant life re-establish as the river evolves. Biology drives morphology, and it'll be a number of years before the Winterbourne settles into a new healthy equilibrium. And that's the restoration we completed on the Chilterns. Andy, if you like to hijack to talk about the reach on the Bourne Rivulet.
Will do. Hi there, I'm Andy, project manager at Wessex Rivers Trust. Can everyone see my screen? I'm assuming that's a yes.
No, it's not
No,
there.
we can't.
Oh, you can't, no?
It's taking its time. It says you've started screen sharing.
Okay.
Hopefully, there we go. It had,
Let me know when it pops up.
it's appeared now. So you're good to go.
Great. Okay, I'm going to fly through these. I've got about 5 minutes, I think. So this is the second project we delivered on the Bourne Rivulet. It differs from the project that Matt discussed in that it's immediately upstream of the perennial head. And you've actually about 15 kilometres of Winterbourne Channel upstream, its catchment. And as a result, you've got really significant sort of flow and also wind power. Um, and similar constraints to deal with in terms of previous modifications and existing development. So I'll go into those and how we dealt with them. So the site that we were looking to address initially this year, it's part of a multi-phase project. We're looking at a kilometre of restoration upstream as well. But the bit that we proceeded with last autumn was a section in red. The firm blue line shows the existing modified channel, and the dashed blue line shows our assumption of where much where the valley bottom is, and but not where the river is now. And that's due to historic modifications associated with largely water meadows, but then also a more recent, or in the past century, history of cress production, water cress production. Through our site, you can see in the red area on the tree right-hand banks, it's flowing from left to right across the screen. There was a large bunded area that occupies the historic floodplain, about 2 meters in height, of gravel waste that's essentially arisen from a century of cress growing. So it wasn't possible to reconnect and sort of restore the valley bottom where it's so quite constrained in what we could do. However, upstream, immediately upstream, this thing like this is where the perch channel to the left of the screen, which you can't quite see, is breaching in places due to large woody material and trees falling in, and is now naturally reconnecting to its historic valley bottom floodplain. And you can see quite coarse vegetation structure growing there. And we think this is a good example of a template of what it probably would have looked like, much less of a defined channel than we see now, and something that we'll be aiming for in future works upstream. However, the reach we did restore last year looked very much like this before. So approximately 10 meters in width, bunded high banks, a lot of waste in the far side of the picture, which is the true right-hand bank that in the valley bottom. Very homogeneous, very uniform, significantly over capacity. This is it in spring 25, this is it autumn 25. So you can see the significant difference in water levels between the two. So these were our objectives. I won't read through all of them. Essentially, what the proposal was to renaturalize the sort of the channel and floodplain as far as possible, with the understanding and acceptance that we're not truly restoring because of the constraints that were faced, in particularly the fact that the valley bottom is now completely infilled. But to do that, we looked to basically increase sort of habitat and hydromorphological complexity by reducing the channel capacity, making a shallower, more bowl-shaped channel, removing bunding and material in. If I move on, sorry, there we go. This is a photo of the works in progress. Gives an indication of what looked like it was a quite cheap project, sub 30 grand, thereabouts, £30,000. So yeah, not spit and sawdust, but fairly affordable as far as things go. No material imported, just using materials on site, large wood material, and lots of regrading. So this is an example of the channel beforehand, and then channel afterwards, looking downstream from the upstream extent. And here's another image that illustrates what the previous sort of channel alignment and plan for like. This is your during work, so last came back. What I want to quickly focus on is a point of sort of interest is in a constrained site like this, where we're not fully restoring to a properly wetted floodplain and potentially taking a stage zero type approach, is how do you size a channel and the large woody structure, the large woody materials within it, to a channel that's got such significant flow and stream power diversity. We actually proposed within our permit and got it permitted 100% woody structures right across the channel. However, being that there's active cress farms downstream and some flood risk or concerns of that downstream, we pull back on that slightly in order to keep stakeholders happy. But this example, the large woody structure at the top of the site, a root ball pulled out from the far right bank, and was put in approximately 50 to 75% channel narrowing, associated grading as well. And what you can see is that gave us, as the water started coming up, this is around Christmas time, you can see you've got a low flow channel there. Obviously no macrophytes developed yet, but you can see the function as a low flow channel, whereas previously that water would have been spread out diffusely across a 10-metre wide uniform homogeneous channel. And then this is it in spring, I think roughly March, and you can see that now those structures are mid-channel and are acting to sort of drive morphological change and hydrological diversity. And so they're functioning in both flow conditions, both sort of nearly dry and then very wet. Here's an image that shows the extent of the site restored with the red circle focusing on that structure I just showed. And again, here a bit more zoomed in, higher resolution. You can see during high flows how those structures then function as opposed to low flows. And you can actually see the sorting of the bed substrate there. You can see sorting of gravels and cleaning. And again, that driving morphological change. It's worth mentioning that there's no macrophyte growth yet. And I think in the winterbourne setting, we'd expect particularly that macrophyte community to really drive hydrology and morphology as well. It'd be interesting to see how that develops over time. And these are a couple more pictures just of various reaches through the site. Managed to incorporate some sort of connected sort of slight backwater areas, very shallow. And this relict water meadow structure at the top of the site, which we're hoping to remove and manage to flood upstream in the next phase of works. But as a quick fix, we put a fish passage easement in there. Something that has been known for years to be an issue is stranding of fish, as Tim alluded to, as the water recedes and rises. So by making some of these structures passable as the water rises and falls, it allows better connectivity for fish species in particular. That's me done.
Fabulous, thank you, Andy. Apologies, I think a few people lost you a little bit through that. I think sometimes the connection was a little bit iffy, but I think we managed to get the flavour of what you were presenting, and the pictures really illustrated that nicely. So thanks very much to the team from Wessex. So now we go a bit north on our journey through chalk stream. So we're going to head up into the Chilterns, and Adrian's going to tell us about a fabulous project he's been involved with on the Hamble Brook. And thank you very much so far, speakers. You are doing an amazing job of keeping to time. So thank you very much. So I'll hand over to you, Adrian. Do you want to share your slides, and we'll just check they're all working?
Everybody else to time, there's no pressure at all.
Oh, sorry. Well, no, we've made up a bit of time, so you're good. No pressure at all, Adrian. So take it away. I can see your slides perfectly. Thank you.
Okay, brilliant. Hello, everybody. My name's Adrian Porter, and I'm part of the Chilterns Chalk Streams project, and I'm here to tell you a story about restoration on the Hamble Brook. So is that changing? Hang on. That's not changed.
No, it's not changed yet.
No. Let's give it a second.
These things always work in practice, and then they always...
Yeah, absolutely. Okay, that's worked, isn't it? Okay, brilliant. All right, that's caught up. Brilliant. Okay, so just a bit about us. So Chilterns Chalk Streams project has been working across the Chilterns since 1997. We're a partnership project. You can see some of our partners on the right-hand side of the screen there. And we operate across the whole of the Chilterns National Landscape, which you can see in green. And we have 9 major chalk streams that we work on, 8 dip slope, 1 scarp slope stream. And the Hamble is to the bottom left, just below the N of National, if you can see that on screen. And we're hosted by the Chilterns Conservation Board, who also have an overarching view of support and education and diversity and improvement across the whole Chilterns National Landscape. So this is about the Hamble Brook. So this is a chalk stream. It's a dip slope chalk stream dependent on groundwater. This is a journey down from source to mouth, and like all our rivers, it's been subjected to human modifications, landscaping, milling, fishing, agriculture, and has to flow through and round properties and farms until it reaches this culvert down at the bottom level. But without a serious treatment works or any urban areas to flow through, the Hamble's actually relatively clean. It has that gin clear water, and it's which is visible through much of its length. But it is a winterbourne, so I'm just going to repeat that same journey, showing the whole river dry down its length. It's reliant on groundwater. The aquifer actually responds quite slowly to rainfall. Sometimes 2.5 months after the rain has fallen, the river will start to respond. And it will go dry over its entire length. There are also periods of low or no flow that might last several years, and during those periods, the brook can be forgotten. It can be moved, it can be ignored, it can be treated like a ditch, and in fact, in one place, it's been turned into a road. So winterbournes do have their own special problems when it comes to restoration. And really, as Tim said, whenever we think about restoring a winterbourne, we've got to consider these low and no flow periods as well as when it is flowing well. Because it's been heavily modified, because parts of it are road and there are some weirs and some culverts, it actually is given poor ecological status under the Water Framework Directive. And really, all this is down to its human modification. So if we can address the human modification of this channel, if we can make it give it space and freedom to function more naturally, we have a chance of actually getting this out of poor and perhaps as far as good in terms of the Water Framework Directive, which is a great ambition of ours. So this particular project, it's about halfway along the Hamble. Bear in mind the Hamble, because the Hamble goes dry all along its length, then really every part of it is an upper reach, because it will be upper reaches at different times through the hydrological cycle. But this was an opportunity at a Colstrop farm. It's a long time in the making. It's a river that we've looked at and studied and walked all over for many, many years. But the opportunity only came in around 2020 when a former farm was sold off and divided amongst a number of different landowners. One of them was hugely enthusiastic and had a real interest in chalk streams and contacted us to say, what could we do? What can I do with my stream and how can I look after it best? And this opened the door to us actually first providing an advisory report and then working with her and her neighbours in order to restore a kilometre reach of channel. The real key for us here was actually she was asking how she should manage the river and the landscape. So it wasn't just a restoration and walk away, it was a restoration and then manage the landscape in order to benefit the ecology. We worked with the Environment Agency and a contractor and the landowner to come up with a plan that was going to sort of be best for the channel, the landscape, and for the people and the heritage who actually have an association with the river. And it was a really good partnership. We did it in 2 phases, and as you'll see, it was required heavy plant machinery in a sensitive landscape. The spring of 2023, if you remember, was actually really wet, and it meant that the water was able to help shape the channel position, but actually it presented other problems in terms of the amount of movement that we were allowed to do with the machinery so that we didn't actually damage the landscape. But and the landowners were worried about the amount of damage that was being done to the landscape. But as soon as the vehicles left, as you can see, it actually looks pretty good. The water's returning, it's starting to settle. And this was November 23 at the end of the second phase of delivery. By February 24, this is the wetland area. The channel there is at the top, running from right to left. You can already see a level of diversity and variety in flow types and habitat and vegetation that actually hadn't been seen in this area for years. Prior to us doing the work, this was actually a sort of a grazed farmer's field. I'll show you a picture of that later. So over 18 months of development and delivery, 2 delivery phases, we managed to renaturalize 1,100 meters of the winterbourne. We worked on 2 ponds, which prior to this were bomb crater in shape and size. We reconnected the channel with the floodplain. We removed previously put in and degraded weirs. We improved the riparian connectivity. We created this 2,500 meters of wetland, planted trees to help with shading, and set up some more set up citizen science sites and did some academic links. So we think we're really proud of this, and it's opened up a bit of work further downstream, which I will come on to in a bit. In terms of feedback, landowners were very nervous, particularly ones who were cognizant of the fact that it was incredibly wet and we were bringing machinery in. But actually, we had some incredible feedback from them. And the one I particularly like is from the landowner who was let's say had a level of cynicism and nervousness at the start. And his is the comment: "If you told me it was going to look this good, I never would have believed you." And I think for me that really sticks in my head as actually we can change people's minds about what a winterbourne should look like. For us, it was the largest channel restoration ever undertaken. So Tim was. I hope this is still right, Tim. We think it's the largest winterbourne river restoration undertaken by the Environment Agency. We were supported by the Green Recovery Challenge Fund, but initially, but actually we managed to leverage a further £3 for every £1 from that fund, and you can see a range of partners involved in it. And actually, that partnership working has generated a model which we think is proving fruit further down the Hamble, and then also on other rivers like the Hughenden at Hughenden Manor. This is a little bit of video. Yes, it is good. That's taken by the Thames Water direct delivery team as a pre-project, and you can see the grazing landscape, the grazing pastureland that was there, very degraded channel. This is the same area over a sequence of months, showing how the diversity changes as the channel develops, as the sward grows over the season. You can see the richness there, which I think is really beneficial to the project, or really a benefit of the project delivery. When it comes to September, here the channel's actually dry at this point, and for me, a winterbourne restoration is only successful if the channel is allowed to return after its drying phase. If it's allowed to re-wet and re-wet successfully, and you can see this image was taken in March 2026, and this shows actually the channel has returned back as a winterbourne. It's able to return as a winterbourne, which for me is very exciting. The project's backed up by a lot of citizen science. We always, with every project we do, we'll do morph and we'll do riverfly, the modular river survey one on the left and the riverfly on the right. And these are citizen science techniques that provide a set of baseline information as to what the channel is doing before we actually get onto site with the machinery. So as part of the design process, influences the design. Because it engages the local community, we train up local community people to do it. It gives them a different lens in terms of looking at the river, allows them to experience the river through different seasons and phases that they wouldn't otherwise see. And because it's their river, we're going onto site temporarily. It gives them the ownership and allows them to hold us to account as to the success of the project. So these are real benefits for us. Modular river survey we can do every 6 months, and that can be done when the river's dry or wet. The river fly survey done every month, you can see where the river has been dry because you can't actually do a survey at that point. So we know this is it's a watching, it's a learning, time has to pass. We will gain more information from the citizen scientists as they continue, and we hope to bring in more survey techniques in order to better understand the dry channel, the benefits of the dry channel on the ecology. We've also engaged with Wild Fish for their smart rivers activity. This actually gives us a really good level of the diversity and abundance right down at a species level for what's in the channel. And of the 5 sites you can see there in the columns, sites 2 and 3 with the greatest total abundance, they're the restoration reach, the measurements on the restoration reach. And so actually we're now taking our attention downstream, where actually sites 4 and site 5 are not looking quite so healthy in terms of abundance. And we've fed into, Tim's alluded to this earlier, the Winterbourne guidance document from the Hampton Isle of Wight Wildlife Trust, Environment Agency, Nottingham-Trent University, and others. The Hamble features, part of the Hamble restoration features as a case study in there. And we want to continue to support this document as we go forward, because this is one of our problems to start with. There wasn't the guidance to how to manage a winterbourne, which we needed and the landowners needed. So we're really pleased that this document is developing. And in terms of what the citizen scientists have found, there are 2 notable species now: the scarce purple dun mayfly, Paralleptophlebia werneri, and Nomura lacustris, the winterbourne stonefly. These are the first recorded sightings in the Chilterns, and these were found on the Hamble Brook after the restoration. So we're really pleased that actually there's a immediate bit of feedback for us. This is just a little bit of shameless video. I think that's a lovely appearance of the stream. You can see the diversity. You can see another spring channel coming in from the top there. That's just one I wanted to show because I just glory in the beauty of a chalk stream. But we're not done. So further down the Hamble, there's this section. So it's about 1.5 kilometers of river. The blue line, if you can see that in the sort of the Google Earth extract, the blue line is the line of the channel. And it's been sort of very heavily modified, moved to the side, and in various places perched. The red circle and the sort of pinky blocks on the left, they're a sign of Roman temples and villas that have been in here. It's a sort of heritage monument site. And those buildings would have been built because of the health of the river, because it had its gin clear water, because it was a reliable source of clean, fresh water. And those buildings would have been built in and around the channel, not 200 meters from it, which is where the channel is now. So we see this as an opportunity to reconnect the channel back with its natural heritage. This is also quite a publicly accessible site. The previous project was a lot of that's private land. This is a lot more accessible. And in fact, there are opportunities here to improve the access to the site. So this is where the people and the heritage actually are really important to a project. The pictures on the bottom actually support the fact that this is also where the channel has been raised, elevated above the ground level for presumably a failed attempt at milling. And so it's a losing reach. It's disconnected from its groundwater. And those three pictures on the left are, just as it comes out of Hambledon. The middle one is about 2/3 of the way down, and then the bottom one is the culvert right at the bottom end. And they are taken on the same day. So the water is flowing out of Hambledon, and it fails to reach the culvert at the bottom, which is the next stop is the Thames. This shows the channel actually is very perched, sometimes up to 3 meters above the valley floor. And in low flows, it means that you break the ecological connectivity with the Thames. And in high flows, the channel can't cope with the amount of water in it. And that's the picture at the bottom right, where the water cascades out of the channel and gets back to where it really wants to be. So we have this program called Not Born Yesterday, which is allowing us to design a project which is really quite ambitious. And the plan on the right-hand side shows a realignment of the channel all the way down through that whole section. The pink line is where we'll actually define a channel, loosely define a channel, and the blue braided sections are actually will allow the channel to find its own route, because partly because there are wetland areas there, partly because there'll be heritage monuments there, but we also want to allow the channel to find its own route. It is the best place to find its own pathway down the valley. So this would actually require the redrawing of an OS map, which for me personally is very exciting. It would mean the channel is no longer confined by the weirs and culverts that actually were put in place in order to send it round its unnatural path. And this is a project which could actually restore the channel back to good on the ecological status from the Water Framework Directive. On the left-hand side, it's just an aerial image, and you can kind of see by the shading, the channel would like to cut diagonally across those fields down into that sort of top right-hand corner. And that's where we hope the channel will be in a couple of years' time. This is in its design phase at the moment. That we hope will complete by the end of May. And so we hope we'll be able to deliver this within the next 2 to 3 years. And this will be our most ambitious project if we get it done. Thank you very much.
Fantastic, thanks, Adrian. Always love to see some drone footage. It always brings it to life, and I've been lucky to go and see that site. So I've seen how great it looks when it's got the water in it, and it's great to see the pictures when it doesn't too. So thanks, Adrian. So we're moving on to our final sort of case study presentations, and we're heading north. Part of the Cabot Chalk Stream sort of remit is to make sure that we're involving everybody in this process, and we're sort of covering spatially all of the chalk stream network. So Matt, you have experience with chalk streams, but I think you're going to talk to us about some things that aren't chalk streams as well, and see what we can learn from that too. So I'll hand over to you, Matt.
Yeah, I just need to work out quite how I'm sharing. It seems to have vanished as an option on the thingy, which is helpful. I'm loving this.
So at the very bottom.
Yeah, I can see him. I can see him. Right, there we go. Lovely. Now, hopefully, you can all see my screen.
We're getting there.
Does it come up?
Yeah.
Fantastic. So, we're going to talk you through limestone, similar to chalk, groundwater systems, and how we've tended to approach restoring them, and then some sort of natural examples of sort of these well-connected sort of stage zero-esque landscapes, not dissimilar to some of the slides we've just seen from Adrian. So this is a lowland, low energy, low gradient sort of flat area of the East Midlands. We had probably the largest and last large fenland landscape which would have fitted this setting of stage zero. Yeah, in this case, you can see on the image on the left that land drainage has been carried out, and the works that we'll have a look at later on involved in filling the channel and allowing it to flow back into its paleo wetland. So really, it's about undoing the centuries, millennia of land drainage, and so we're looking at what the landscape perhaps would have been in the past: more complex, more varied, more complex, wet landscape, and really biologically controlled, which the river presenters have touched on. So things like toother, beavers, trees, aquatic plants, and very importantly, very low or no sediment supply, non-alluvial rivers, some of these, gin clear in high flows. But these subject to a lot of change. You start felling or deforestation, you increase the sediment supply into these rivers, you take away some of that vegetation, and yeah, they're capable of changing. So what do we mean by natural processes? Well, it's biology, it's ecology. This is TUFA doing its sterling role in actually resetting the landscape, delivering its own stage zero. So you can see it's formed over the fence line there. So in that time period, the fence line's been in. This is formed, and that's largely a biological process. It's degassing, it's chemistry involved, degassing of the carbon dioxide, which helps precipitation, but there's the biological processes of microbiology, everything from bacteria and viruses up to the plant communities and bryophytes, liverworts that are helping the tufa form and provide that roughening effect for it to deposit out. So here are some existing sort of stage zero natural landscapes, and again, tufa related. So you can see on the image on the top left, you can just about make out some of the tufa structures which we've mapped in here, and these help to dissipate the flow right across the whole of the valley bottom. And this is a nice little tributary of the River Nene. And both in the channel as well. So these form these little barriers, often attributed to wood blockages as well. They tend to form around wood, and these lift the water up and spread the flow across into multiple thread channels. I quite like this image. It almost looks like you could be, I don't know, using your imagination, flying over a forest or something, looking at a braided system rather than looking on a micro scale at the mosses in this lovely woodland example of a spring line. And you can see the role that wood plays in dissipating and spreading that energy across, and you can also see it's being petrified and turned to stone, and that's how the river creates its own sediment supply. It doesn't have a sediment supply, it's non-alluvial in terms of material coming into the channel, but what it can do is it can create its own gravels and rework them. Its gravels might look like tiny fossilized bits of twig or leaf. Out in an open landscape, tufa hasn't got the benefits of the wood, so it uses its vegetation again. So it's using sedges, rushes, it's using the mosses, the bryophytes, the grasses to form these almost series of terraces or little mini paddies across the landscape. And absolutely beautiful, only probably, I don't know, a couple of inches tall maybe, easily lost to agricultural grazing pressure. Where we do find the multi-threaded channels rather than sort of dissipated flow across the landscape. We see that in connection again with tufa and wood and your vegetation there, your plants. And this is one of the limestone becks where it multi-threads through a wet woodland, which is rather lovely. So before we consider the restoration, we need to understand the site and do some investigations to ensure what we're doing is appropriate to the landscape and is the right restoration technique in the right landscape. So again, you can see we've done a series of soil causes, transects to try and understand the past, and you can look more into that and look at samples and dating. And what we found from looking at this is that there are now very, very deep anthropogenic clay deposits capping the organic clays and then shallow deposits of gravels. And it indicates that in the past, prior to these deep deposits of sandy clays building up, that it was a high groundwater environment. So that tells us that, yeah, raising the groundwater is important, stabilizing the groundwater is important. And then the image on the bottom left is before work started, snowmelt event showing the paleo wetland that once existed prior to drainage. And then the image on the right is what it's returned to once we've filled in the drainage channel. These are some more historic works that we've carried out in 2015. And really this is, for us, it's about reversing land drainage. So by using beaver dam analogues and wood, we've managed to re-wet up the wet woodland, and that's now transitioning. The birch is dying off and new species are coming in, which is rather lovely. And then this is a more fenland setting where we've done the same at a low gradient section and re-wet the landscape. So this is interesting. I'm sure we will all have different perspectives on this, but how wet do we want to get these landscapes? So in this instance, we might have been too successful because now it's too wet to manage for the floristic diversity and the botany interests. And we may see a transition towards fen rather than wet grassland. So there are discussions about whether we can actually lower the water table so that yeah, we can get it to a balance where it works for the site management and the habitat that's evolved already. And then ultimately, my favourite approach is the beavers and how they manage stage zero landscapes. So here you can see a clay catchment that they are terraforming, creating lots of wetlands through digging canals and ponds. And then we get to the monitoring benefits. So these are the monitoring we put in on the earlier project that we started with at Grange Farm, the Stage Zero project. And we can see a losing reach before work started, and then a rise of groundwater 1.5 metres since. And a change in the wetted perimeter. And this is quite lovely. So this was taken in a low flow year in 22, and you can see there's a slight tinge of green hugging the shape of the channel. And as we come round the corner, you've got a wet flush coming in the spring line, and then compare that to an image taken in our drought conditions, actually. And you can see not only is the full valley floor wet and green and lush, but actually up the valley sides even. It's also green. So we have literally re-wetted the riverscape, which is great if you're thinking about climate change resilience and low flows, but also from an agricultural perspective, providing grazing. And then the benefits of reconnecting that lateral connectivity and giving refuge for life to escape from high flows. And then really just a final couple of philosophical ponderings. The only really definable key parameters I can see for stage zero tend to be the full valley floor floodplain reconnection and a high stable water table, which does sort of vaguely sound like existing healthy chalk streams. And on the unhealthy chalk streams aspect are some chalk streams, stroke ditches, technically or cost effectively feasibly unrestorable due to these pressures, especially of abstraction and public water supply, and would perhaps creation of a different habitat be better than what's there if we can't go back? Lastly, I'll just leave you a nice image of stage 0 with the Northern Lights. But yes, the monitoring has been carried out by academia, and it's been one of the great privileges I've had with working with lots of really passionate and keen people that have the time and the energy to do this research. And I would recommend people build those academic links. Thank you.
Another fantastic presentation. Do you know what? You have all been amazing. If all of the presenters would like to put their cameras back on again, you're amazing because your presentations were all excellent and all touching on different aspects of this, which I hadn't necessarily expected when curating this fabulous panel setup. But it's been really, really great, and you have all met the challenge of delivering the projects to time. These webinars are generally quite well attended, and I think it's because they're quite short presentations that people can just get a dip into a project, and then they can find out more if they want to afterwards. So a huge thank you to all of the speakers for being on time and being amazing and really inspirational. And touching on so many different aspects of restoring the upper reach of the chalk streams. So David, I'm going to feel a bit bad now. I'm going to kind of hand over to you. Hopefully you've been taking a look at what's coming in on the Q&A. We've got 6 by the look of it, some varied questions in there. So I don't know whether you can kind of either answer them or farm them out to the relevant people. And the panelists, if you want to have a look and see what's in those questions too, and be prepared to answer any of them. So I'll hand over to you, David, if that's okay.
Brilliant. Thanks, Alison. And again, thanks to the speakers. Goodness me, that was a miracle that you kept to time. So well done. And really, really nice examples, quite diverse examples. And you have prompted questions. I'm not allowed to ask questions through the official chat, but don't worry, I can't not ask a few. But let's start. We've got some people here. Jason Winslow asks, he's asking Adrian Porter, but actually I'm going to encourage all of you to answer this, if I may. So perhaps starting with Adrian, as it's aimed at you. What was the single biggest challenge you faced during the planning, delivery and monitoring of your restoration? That's the first one. And then linked to that is, what would you do differently having learnt from those challenges?
So I think our biggest challenge is actually it's funding and the ticking clock. We had, these projects take an inordinate amount of time to design and develop in a way that actually you get everybody on board. The consenting process takes a lot of time as well, and all that time the clock is ticking. And in fact, we lost a bit of funding because the clock ran out. The only time we could actually the only way we could deliver the project was there was the brilliant Leslie Sproat in the Environment Agency actually walked round the desks of the various people to provide the authorization to actually get to give us the consent to actually deliver the project. We were right up against it for time, so that's our biggest challenge. In terms of doing it again, what I would do is, I hadn't anticipated quite the change that was going to be made to the wetland area. So actually that was a huge bonus for me. I was focusing much more on the channel diversity and making sure that was going to work. So I would put in a whole load more sort of baselining on the riparian area to see what the botanicals are, the macrophytes are in there, in order to assess the positive impact of that, because we don't have the baseline data for that wetland area. But that's the area I'm most fascinated by, to see how it changes.
Brilliant, thanks. Now, perhaps the others could come in. Perhaps the Wessex Rivers Trust people, could you say something similar about your single biggest challenge and what you would do differently? Matt,
yeah, just unmuting. Yeah. Do you want to talk about St Marybourne, or do you want to talk about, shall we talk about Hinton Ampner?
Why don't you start with Hinton Ampner and then switch to Andy's St Marybourne? That would be really helpful.
Yes. Similarly to Adrian, particularly last year, there was a real challenge of time to we had to get our sort of fraps in as earlier than ever, due to the sort of nationalization of the permitting scheme, and that obviously proved difficult. And this was the Hinton Ampler Reach was delivered under Watercress and Winterbournes, which last autumn was technically its last delivery season to use the funding. So we had to pull together a design for that reach in a short notice. And in hindsight, if we had more time, I would have liked, so upstream of my site, there's another landowner, and we just didn't have enough time to engage with that landowner to tie in both sites. And then that would obviously extended the reach, but also we could have looked at, because the reach that we're working on is quite disconnected from its floodplain, we could have looked at more bed raising efforts and that kind of thing and tied them in, which we didn't have the time to do that. So we only could do some of those sort of minor bed raising. And Andy?
Yeah, I think for St Marybourne, I think it's, as I mentioned, it was part of a wider project. The reach we did last year was only a few hundred meters, but we're looking at about a kilometre upstream. I think the tricky thing, I mean, with river restoration in general, but particularly with the Winterbournes, is that constant question of what it should be. What are we trying to restore to? And we did a fair bit of investigation, but I think we still probably aren't entirely sure. And with the reach, both the reaches Matt and I presented on, I think we justified our approach in that we went into quite a lot of detail on what the constraints were, whether they were road networks, culverts, all that type of thing, flood risk. And I think we probably maximise the benefits within those constraints. But in an unconstrained site like the one I sort of alluded to upstream, and same with Matt, I think it's making sure that we're absolutely certain that or with as much certainty as we can, that we understand what we should be restoring to. And I think that's a technical challenge, really.
Brilliant. Thanks for that. That's a really good statement, because I think perhaps if Tim and Matt could perhaps pick up on that in the context of what would you do, or what's the big challenge in restoring Winterbournes? I personally think you should start with what on earth are we trying to do, and what evidence do we need? But interestingly, and I understand it because you're practitioners, it's that you've come back with, goodness me, it's about spending the money in the right amount of time, which of course is entirely the wrong thing to drive any restoration of a sensitive ecosystem. So I'll pass that to Matt and Tim to perhaps comment on. What should Winterbournes look like?
Shall I go first on that, Tim? It was something that I was, thinking. It was actually my answer I was going to give as well, was timing and funding. Because the way things work with the delivery program and your sort of the momentum of forced being delivered, we don't often have enough time to really get to understand and ask all those questions and get the grip with the landscape. So trying to get funding to look into these things is quite challenging. It's not seen as essential to the restoration process. It's seen as a nice to do, perhaps. Whereas for me, I need to understand the past and the present to have an idea and an opportunity to even have a clue what to predict in the future. So it is really important. And I don't ever feel like I've ever got enough time really to do the projects to the level they should be at, because time is a constraint. You're delivering projects across a large area, and actually I'd love a bit more time just to go into get out there and do those soil cores myself and really get to understand this better, rather than having to put it out to contractors and just pop in for a short session to look in at what they're doing and then interpret things.
Tim.
Yep. Well, there's no right answer, is there, Dave? But that's why you asked that question. I think generally we should adopt a principle of doing no harm. Much of what we do is fairly temporary, is fairly ephemeral in its nature, and putting large woody debris or material in a river, isn't permanent. It will move, it will rot, it will disappear. And so I think a lot of what we do isn't likely to cause long-term harm. I think we can also, the general principle of, if we move a perched channel to the valley bottom where it really wants to be and where it will eventually, given enough time, end up. What we're really doing there is speeding up natural processes in time, and we're reversing damage. So I think principles like that, we're unlikely to cause harm by allowing the water to flow where it wants to go. It's if we were to do something more permanent, perhaps, I think then we might be just repeating the errors of the past in terms of over-engineering channels. So I think a lot of what we've seen today is really very subtle and is reversible over time, and therefore I think isn't harm and is just speeding up what might happen given enough time anyway. Yet, if I may change the topic slightly, I think another challenge is, and Adrian alluded to it, and I know the Wessex Rivers Trust have experienced it, and we, the agency, have too, is that often landowners have cold feet. And so the quote Adrian showed about a landowner, we are quite often are approached by landowners who declined to collaborate with us on a scheme until they've seen how great it was on their neighbours. And then they say, I'd like a bit of that, please. And having declined, it's quite frustrating because then you're missing opportunities of economies of scale and things like that. And so now we're gathering more case studies. We really want to be able to take people and show them this is what it looked like before, this is what it looks like now, and to get people on board, because I think with such fantastic case studies, we might get more people enthused about participating. Thank you.
Great, thanks, Tim. I mean, that does presuppose what we're doing is the right thing to be doing, because of course, if we're not, and you keep putting up wonderful case studies of things that ultimately 20 years down the line don't deliver what we want, then we'll probably look back and say, oh. So a couple of other things that have come up about land use around these winterbournes and coping with that. Perhaps we can take these in terms of, for example, many of the sites here. This is Libby Pool. Thank you, Libby. So many of the sites have a sort of species poor grazing pasture. That's what you've been restoring within. Anyone have any advice on working with botanically diverse floodplains? So how does essentially all these sort of excavators and things churning up the ground, how quickly do botanically diverse floodplains bounce back from that? That's quite an interesting point. I don't know if anyone wants to comment on that.
I don't have experience of working with botanically diverse floodplains, but I don't think we should be, we did bring heavy plant machinery into an ecologically sensitive area. And actually, although the photographs look quite damaging to the land, if you are careful about how that machinery is used, there is no reason for it to cause long-term damage that would prevent any form of recovery. So you can use low ground pressure machinery, you can minimize movement. And if you use the right environmental contractor, then they can feel with the digger as well as you can feel with your hand. And actually, I was transported back to being a little boy watching these diggers. The artistry and the care with which the digger driver was able to sculpt the landscape with his 360 was fantastic. And when they left, they put all the topsoil back, and actually, so that contains a seed bank, and so there's no reason why recovery shouldn't happen within one growing season as it did on our site.
Brilliant, thanks, Adrian. And one thing to pick up on, I think the value of those seed banks is quite often overlooked, not just in terms of the soil on the floodplain, but the seed banks within the old channels, in terms of not digging them out and seeing them as spoil to be removed, but actually as a seed bank to help reseed the new channel that you put in. Anyone else want to comment on floristically diverse floodplains and restoring within them? If not,
yeah, I think I've got something to add there, that it can be a constraint in some elements, that having a floristically diverse meadow in a landscape that's largely pretty anthropogenically knackered, means that species that might be more common elsewhere actually have a lot more value in that landscape. So it's that awareness of what you've got to start with and what's evolved over time, and that it also has an ecological value alongside what you're trying to do your restoration works. And my preferred approach to this is to do this over a period of time. So you're not exposing within 1 year extreme change, but you are allowing the river to do the work, and ideally raising those water levels and undoing the drainage that was done over a course of years to allow things that like it wetter to move towards the wet and things that like it drier to move up the valley sides.
I think that take it slower and careful is actually a good point to make, but of course it flies in the face of everyone's earlier points about you've never got enough time because the resource has to be spent. So either we're doing things badly, or actually don't we need to change that funding mechanism? And if there's any government related people on this call, there's a very strong message about changing that funding model. Brilliant. Look, thanks for that. There's an interesting one from Andy Roberts here, who's actually sort of saying, well, look, this is all very well and good, but an awful lot of our chalk streams have got these water meadow systems. So essentially, what should we do when we've got water meadow systems? I'm going to expand that slightly. Some work I've been involved in looking at floodplain inundation in heritage landscapes. There's an awful lot of heritage out there that modified the subtle topography of our floodplains. So going back to the past, of course, which is lovely if you're in Oregon with your stage zeros, not quite the same when you've had over 6,000 years of cultural modification of the topography. So your inundation patterns won't necessarily look the same. Water meadows are a brilliant example. What do we do? Jump in, anyone.
I mean, I think it raises the question, but yeah, which is so ubiquitous across river restoration, which is like, what are we, what are we restoring to? Which age are we trying to restore to? And I know that's not just relevant to winterbournes. That's relevant to probably also to habitat restoration. But I think in a lot of examples, there's probably a middle ground where you can certainly look to go away to restoring hydrology and morphology of some of these really degraded channels, whilst utilising elements of the historically modified floodplain, like that water meadow system, and that could be incorporated into the design. It might not be that, you might look at it idealistically and think, well, we just want to completely regrade out this whole field system and reset it. But actually, as Matt Parr mentioned, there are constraints, and it might be that's a constraint too far, and there's a middle ground there. And I think that's probably in a lot of cases the way forward, where you've got those sort of real heritage implications or constraints.
I also think it's a bit of a pant-array, so that no person that walks into a river is, the river or the person is not the same twice. Same with the landscape. What we're seeing is, a snapshot of time of what the landscape looked like. And I guess it's about understanding that you probably can't go back, but you can look to the present and the future and see what the pressure is going to be, and perhaps build in that resilience. So perhaps if we're thinking about climate change and low flows or shading of water.
Thanks, Matt. That's another question that somebody else brought up, and that is, what were the constraints of abstraction in these case studies, and how did you accommodate those? Perhaps we could start with Matt and Andy on the Cheriton, and then go to Adrian and Matt Parr on the other streams. Was abstraction an issue, or for those on the call that are dealing with massively abstracted landscapes, how relevant were your case studies to them?
I can jump in there. I mean, the reach I was at was very close to the perennial head, but the perennial head is somewhat artificial in that location due to abstraction for cress farming. There's a large cress farm adjacent, and it's probably actually a slightly artificial perennial head. Would have fluctuated upstream more significantly in the past and had more variability. But I think it's all about building that, that flow resilience and drought resilience in. I don't think there's much else we can do. We didn't have, we had data sets that we could look at, but it was fit into our design somewhat. We were basically looking at a channel that's incredibly modified, like I say, incredibly homogeneous, way over capacity, really suffered with those fluctuations in water level in terms of the habitat, response. And I think applying that to the same basic principle of undoing the damage and trying to sort of effectively resize the channel to something that's more appropriate and build in that resilience so that you can build in that adaptability, so that the channel can expand and contract, with macrophyte structure and all the rest, is probably the best you can do. That's certainly the best that we could do anyway.
Okay, great. Thanks, Matt. Top of the Cheriton.
Yeah, there's no doubt that abstraction has an effect on the aquifer there, but it's difficult to quantify that because we're as I said, at the very top of the catchment, and this is about 100 meters downstream of the recognised source of the Itchen. So what we did is what I echo the same as Andy. We just changed the channel because it was a sort of box-shaped modified channel that it couldn't adapt to the various flow levels that it would receive throughout the year. So we just restored it to a more natural profile, which will hopefully provide that drought resilience.
Can I come in there, David?
Yeah, please.
Just to be slightly controversial.
Good.
I'm not sure if abstraction is a red herring or not. In many of these headwaters, abstraction has gone on for decades and varies very little. So I just put it out there that maybe abstraction has just created a new baseline that has not changed over decades and is unlikely to change for decades to come. So maybe in many cases, it's just it's established a baseline with which we have to work. It would not be possible to design schemes for potential changes in abstraction that might be decades away. So it's not a reason not to restore winterbournes. And I'm wondering if it would even be feasible to try design them to account for abstraction, given it's so relatively stable and long term.
David, can I jump in really quickly?
Jump in, Alison.
It's abstraction, isn't it? It's my thing. But really just to make the point that in terms of managing the chalk streams, we obviously have the trinity of ecological health, which many of you will be aware of, managing, flows and water quality as well as morphology. So we're focusing necessarily today on morphology. But there is a lot of work happening within the wider Cabot Chalk Streams programme. So you may be aware of a project called, and I always call it the wrong thing, I think it's called Head Start, but it's focusing very much on the value of headwater reaches and particularly focusing on improving water quality for the examples we've had, I don't think have been massively affected by water quality, but they are in other places. And Tim, you're quite right, in some places, abstraction stable. In some of our chalk streams, there are massive impacts from abstraction on headwater reaches, but there are also plans to address those. So we might actually see winterbournes suddenly getting flow back in them more so than they had before. The Chess is an example in Adrian's patch of where abstraction's reduced. So I guess it's a plea for making sure that when we're working on river restoration projects, we're having a little bit of an eye over to our colleagues working in other parts of chalk streams through catchment partnerships and all the great work that goes on there, looking at what is going on and what changes are likely, and the big one, climate change. Making these winterbourne stretches more resilient to whether it be abstraction or climate change is really important.
Thanks, Alison. Just to pick up on that, these are isolated reaches like almost all river restoration projects. And a question I had to you all was, to what extent did you consider the upstream fine sediment loads coming into your rivers, your reaches? It's particularly an issue in winterbournes because quite often they're ploughing upstream at the top end of your winterbourne. or indeed, as one of your case studies showed, around and about it. Thinking about the hyporheic, which is the flows of water in the gravel beds and sediments around a channel. Of course, if you plug it with fine sediments, you break that connectivity. Did any of you think about the upstream fine sediment loads? And if so, how did you do it? And what was the effect on your design? And if you can say, no, I didn't do it and I should have done, that's just as well. Adrian.
So I didn't take into account in the design, absolutely, but I do know where the problems are upstream that I need to address. There is a farm upstream where there's a lot of horse grazing. I know that's a source of sediment into the river. There's actually a spring that appears on the wrong side of a road, spreads all the way along the road and carries a lot of roadside sediment into the channel as well. And then at the top end of the catchment, there's actually where the Bourne actually adopts a road, it picks up a lot of grit and silt from there as well. So I know where the problems are. Do I have a plan to address them right now? No, but they're on the long term list of how to improve the Hamble Brook. But I don't have a solution today.
Look, I'm going to bounce back controversially, Adrian, and yet you want to go ahead with an even bigger project without actually tackling potentially one of the big pressures on your river channel itself.
A lot of the work we do in river restoration, I think, is regarded as opportunistic. I did a project in Chesham, which was at the time quite controversial, but actually has turned out to be very successful. And people were saying to me there, this isn't the biggest problem. The bigger problem is that bit upstream or that bit up there, that bit up there. We'll go, well, actually, I've got an opportunity to fix this bit here. So actually, this means that as long as I'm still planning to address the problems upstream, then it means that the section I am restoring has the best opportunity to thrive once that bit is done. And it goes back to that sort of triangle of ecological health. If I can improve the habitat and I can improve the flows in that bit of river, then it will only get better if I can solve the upstream conundrums.
Dangerous thinking, Adrian, because of course you've built yourself a wonderfully rough, rugged, and a very effective sediment trap. So good luck with that. That's why monitoring is really important. So see you in 20 years.
Yeah, absolutely.
But I think what you're saying is if you had all the money in the world and the time, you'd have probably treated the wider pressures first before you went in and restored the channel, if I'm not putting words in your mouth.
Yeah, I think that's fair. And if you've got the smarter water catchment type programs, the flagship catchment, the Pang is now a flagship one. So these sort of whole catchment approaches allow you the time and the energy to do the right research in order to tackle the problems, ideally in the right order. In smaller catchments which are less funded and they are more opportunistic, then you don't get that chance, and you take the opportunities when you get them. But to consider the wider catchment is really important in river restoration. You have to know what's going on in the bigger picture in order just to resolve the problems in your reach.
Couldn't agree more. Thanks, Adrian. I'm very, very conscious of 2 minutes. I'd love the others to come in. There's a little point from Charles Rangeley Wilson, who's currently probably in a shepherd's hut in New Zealand. He's actually put a plea out there. What examples do we have of natural, unmodified chalk stream winterbourne reaches, if any? Please, if you've got any of those, can you let Alison know? It would be really, really helpful to have a look at those. I know there's some reaches on different river types. Chalk river types. So yeah, if the more the merrier of those would be really helpful, I think, to help guide our expectations. So look,
I better wrap up, I guess. Sorry, David.
Yeah, I was going to say, are there any final points that anyone wants to make quickly in the last dying minutes before wrapping up? Alison, perhaps take that.
Yeah, so I was just gonna say this was a bit of an experiment. I think from the comments I've seen in the chat, I think people have really, really enjoyed the presentation. So again, another round of thanks to all the presenters. Hopefully the discussion's been really useful as well. I noticed a lot of people have stayed on the call. They haven't disappeared. So I'm guessing that people have found the discussion useful too. I really, really appreciate your thoughts and views on what would be useful, how to develop this idea of a community of practice hub, particularly any offers of case studies that people have got. Tell us about projects you've got coming up that maybe you'd like to share some ideas around, and also ideas for, if this has been helpful, we pick the topic of headwaters, we can pick another topic and focus on that in another call. So just really want to make it useful. So, and to do that, I need your ideas and your thoughts. So please, I've put my email address a couple of times in the chat. Please do get in touch with suggestions. River Restoration Centre conference coming up. There will be a chalk stream session, so see you there if you're going to the RRC conference. And yeah, just really welcome your feedback and your thoughts. Thank you very much, David, for chairing that final session. Thank you for Becca for running the event for us. And again, thanks to the presenters and for everybody for attending and providing great questions too. So enjoy the rest of your day. Get out, see a chalk stream if you can. It's finally sunny again. So thank you very much, everybody.
Cheers.